Sawadee-ka. That's the only thing, so come on. Okay, hi everybody. Thank you very much to come here. And my name is Inaki Villar. I'm an Android developer working in Agoda. And I'm going to talk about advanced Android topics because, well, I think that everybody has spoken about the other topics, right? So I have to speak about this. And before I start, this week, last week, O published this article this post in Facebook saying about 2 years ago, there was like a big Google I/O extended, and it was, well, awesome, right? Because it was the first for a lot of people, including me, that I was just arriving to Bangkok, and since then, so well, I don't know. So meet like Tank, T, all of course, Egg, and the new guys like Bert, you, and it has been a pleasure. And I think that we have to continue growing the community in Thailand, not only with the GDG, of course, but with other meetups too. Okay, so I'm going to talk in 3 parts. First is going to be testing, so what's new in testing for Android. Then a little bit about the new D8 compiler, R8, and finally about Android runtime. In terms of testing, nowadays, so we have this picture, right? So it's very clear that in terms of testing with your local machine, we are using the IDE, and we are using, in that case, Mockito, JUnit, and Roboelectric. If we want to execute integration test, we have to use like Espresso, the Android testing support library, and even Roboelectric can be considered things. And this is like this way for everybody today, right? So if I want to write a unit test, I have to write with my laptop. I mean that I have to execute in a JVM. The unit test is going to be executed, and so on and so on. If I want to execute integration test, I have to use a device. What's new in Android test? So first of all, Android test, or the testing of Android, remember that previously we were using the Android testing support library. Now, so today, is integrated in the Jetpack. So the same thing that we were saying with Egg at morning, or morning after lunch, so that means that you can use Android testing there. And what's inside? Well, you can guess, like Espresso, the Android JUnit runner, for example, all the new assertions library, and the Kotlin that they are preparing for the testing. Everything is going to be open source. And I think that now, actually, you can use in Android X. So, Roboelectric, well, who likes Roboelectric? Please, raise your hand. Don't be shy. Nobody, right? Oh, well, really? You like Roboelectric? Okay, well, so I mean that, well, as developers, we hate Roboelectric, that's the truth, right? So, I mean, that's the truth. We try to isolate the logic, the business logic in the code, right? So, and before, when we were not used to work with testing, so our activities were very large, right? And we have to test, and we were using Roboelectric. And so far, so good, right? But in terms of clean architecture, clean code, whatever, we need to isolate the code from the activities because the activity belongs to the platform. And this is how started or hate to Roboelectric, right? So everybody hates to testing with Roboelectric. It's slow, so it doesn't support some parts of the platform. Every time that we have a new API version, there are problems. But now I'm a Roboelectric lover. So what happened to change that? During the same day in Google I/O that they were presenting the new stuff of testing, Roboelectric 4 was released as alpha. Roboelectric 4 now is working with Android X too. So belongs to the Jetpack. And that's a good movement. Since last year, I remember Roboelectric belongs to Google, right? It's not an independent library. And the best part is Roboelectric is supporting Espresso. Not only Espresso, or supporting the Android unit runner, is supporting everything. What's mean is, if you see this test, it's a simple Espresso test where we are using the Android unit runner, the activity test rule, and we are doing a stupid assertion. This test you can run for Espresso and Roboelectric. So this is awesome, because the same test that you have actually with Espresso, you can run with Roboelectric in terms of unit test. This is great, because if we analyze with a build scan, for example, one connected Android test, that the task to run our automation test, so we can see, this is for a simple project, that we have an overhead of some tasks, like connected, well, we have to execute the test. And remember, when we are executing an automation test, we are building the APK and then the test APK. So it's double everything. We are using the transformation for the text files, so it's an overhead. With the same test with Roboelectric 4, we are using a normal unit test task. And that's impressive, because here the difference is not huge, because it's a simple project with one automation test. But well, so if you're working in a big project with maybe 100 automation tests, maybe with a lot of dependencies, these times are increasing a lot. So for the same task, we have 23 seconds for Espresso and 7 seconds only for Roboelectric. So quite impressive. And when you should use this part, because at the end, so if I'm running automation test, I want to ensure that the device, to run the test on the device. My recommendation today is like, if you're using Firebase Test Lab, it's one service that costs money, right? And if you integrate in your pipeline of CI, execute 200 tests every time that you're creating a pull request, it's going to cost money. So one approach could be that for pull requests, maybe you can use a simulated device, and for maybe a regression or daily developed builds, you can use the Firebase Test Lab, for example. A little bit spam. So I wrote an article about this 2 months ago. So if you want to check how it's building Espresso test with Roboelectric, here you have the article in Pro-Android Dev. And well, the good thing is like you can use the same libraries extensions that you are using in Espresso, like Cacao, you can use for the unit test too. Impressive. But this didn't resolve one problem that actually this is generating. So I was saying that I can execute one test as unit test and the same test as automation test, but I have to duplicate the test. So it doesn't make sense. And in the same presentation, they announced Project Nitrogen. Project Nitrogen is a single entry point to execute the test, to avoid this problem of duplication of code. This is going to be available at the end of the year, we hope. And how it works? Well, if you are familiarized with automation testing, with Android testing, so Nitrogen in this slide is trying to organize from the installation of the APK and test APK until imagine that you want to disable the animations, you want to enable or accept permissions. All this stuff is doing Nitrogen for you. And then it's coordinating the execution of the test. If we see the same slide from another perspective, last year Google released Orchestrator. That's a new runner to have a stateless test when you are running your test. and is coupled with nitrogen. So nitrogen connects to Android test orchestrator that at the same time is isolating the test in the JUnit runner. And this is the whole picture of this. Before, if you want to run a test, for example, and I want to run from the CI, I have to specify where I want to run my test, whatever. With Project Nitrogen, you forget about everything. You forget about everything. So you connect with Nitrogen, and you can decide if you want to run your test locally, in Firebase Test Lab, in your solution, custom solution at the office, or even with Roboelectric, without the duplication of the test. The title of this talk in Google I/O was "Write Once, Test Everywhere." So that's the idea. If you remember the first slide about testing, I was commenting, so now as developers, if we want to run a unit test, we have to develop locally. We have Mockito, we have Roboelectric to run this unit test. If we want to go to automation tests or integration tests end-to-end, we have to run with Espresso, with Android testing support library. Now, well, when Nitrogen comes, it's going to be, you have to forget about these different configurations. To develop, you will have Android Jetpack, Android testing in Jetpack, and to run the test, you will have Nitrogen, Project Nitrogen. So again, let's wait until the end of the year, but looks great. Looks great because we are having different configurations, tests, Android tests, whatever. So, and this is going to fix these problems. Okay, the second point to talk is about V8, R8. It sounds like the Star Wars, right? So the R2D2 or something like this. There was some tweet of Jake Wharton because some guy told me, why is called V8? And Jake Wharton was saying that they were in a whiteboard and it was decompiling, and the guy thought that compiling DC it was an 8, but whatever. So I mean, it's not clear from where comes the name. First of all, before we are going to see the same topic that Egg commented this after lunch, so we need to understand how it works and why this improvement inside the Android framework. So this is the basic picture of how it works, since you have a Java file and a Kotlin file. So when the Kotlin compiler or the Java compiler is generating a class file, a bytecode file, and then we need to translate this bytecode to the Dalvik bytecode. That is going to generate a DEX file. DEX file means Dalvik executable, and then is the APK that is going to use this APK, this DEX file. Sorry. We are going to center in the part of the classes texting APK because how it works internally, Kotlin compiler or the Java compiler is out of the scope. So in terms of the class, if we analyze what inside a class, what's generating Kotlin compiler or Java compiler is bytecode. Okay? So I think that now we are more used to check the bytecode since we are working with Kotlin. And what's inside the text file is a Dalvik bytecode. It's not the JVM bytecode. And why? Because the Java bytecode is, or the Java virtual machine is executing the bytecode in a stack. And the Dalvik one is a register. It's one of the main differences. So think that still that we are using a virtual machine in Android, the bytecode has to be optimized because it's not the same like a smartphone, like a laptop in that case. Okay, and what is this text? So if you are an Android developer, I'm sure that in your life you have had one problem like this, right? So everybody has one problem with the text. You know that by default, by design, so the text file, it cannot contain more than 65,000 reference of methods. And 10 years ago, 9 years ago, it was okay, but now it's impossible. You are using dependencies with analytics, with Google Play, with, I don't know, all the Square libraries, and it's very easy to play that. And that's something that is almost sorted, but still, today, you can have a lot of problems. And this solution comes from maybe 9 years ago. And that's why we needed a new Dexter compiler. And by Dexter compiler, that means that once you have the bytecode of Java, you have to translate in a Dalvik bytecode. Previous Android Studio 3, the plugin 3, this was the process. We have Kotlin Java, compilers, indexing, and then the APK. What happened here? You know what is the incremental builds? So incremental builds means that when you are working with your project and you change one class, you don't need to recompile all the classes of the project. You only have to consider the new bytecode change. This means that it was working well, the incremental build in Android, but not the dexing. The dexing was not affected. After that, in Android Studio 3, plugin 3, it comes a new way to do this approach, and it's called incremental texting. And that means that every class is generating a single dex file. Not like before that we were generating one big file. Now we were generating one by one, and then we are merging the results. And that's why now we have incremental dexing builds in Android. If you change one single class, so you don't have to recompile all the project. You don't have to, again, generate the dex files of the other classes. Now it's more clear. But if you are using an annotation processor, the incremental dexing is broken. Good news about this. In Gradle 4.7, incremental dexing is fixed. In Android Studio will be available on 3.3, I guess. Still, we are officially in 3.1, but it's going to improve a lot of our work. Okay, so we have this dexing generating multi-dexing class, and additionally, we have the problem with the sugaring. The sugaring, as we saw before, if you are using Java 8, features of Java 8 like lambdas, you need somehow to translate the Java 8 into compatible Java 6, Java 7 code. D8 is doing now all the process with the desugaring and with the dexing in one step. So before, the sugaring was provoked by a transformation API call, but now it's all together and it's faster. This is the same slide that we saw before with Egg, and you can see that the speed has been improved. But in Agoda, we have tested already the D8, and we are working with D8. And these are exactly the improvements. So in Agoda, we had one problem until last month with the main dex file that we had to use ProWar in the back builds, because we had a lot of reference in the main dex file. Another problem of design of the dexing, of the whole dexing compiler. In terms of the back, we have reduced 56% of the size of the dex file, of the main dex file. In terms of release, it's 75. So it was perfect, the change. In terms of time for the back builds, so we have decreased 10%. So in that case, we have working with D8, and so this is the strategy recommended by Google actually. So because maybe you were wondering when I have to put the D8. The first phase is now, and you have D8 and DX to work together. You can choose one or another. This is going to be 6 months. Later, we will have a second phase where DX is going to be full deprecated, 1 year. And after that, DX is going to be removed from Android Studio and the plugin. So don't leave the things for the last day, because, again, they're not free of problems or bugs. For example, with the version 3.1, we are having problems with the nested lambdas of Kotlin, and it's not fault of the Kotlin compiler, it's the D8. So it's better if you can test the new D8, because it's going to save time for you, right? For us, it doesn't represent any problem with 3.0. With 3.2 alpha 15 or beta today is working okay, but it's better if your company, your projects try to check more things about this. Okay, the other part of the D8 R8 is the R8. R8 is the new shrinker or ProWard tool from Google. To understand a little bit, now when we are not using R8, even that we are using D8, this is the structure. So first, compiling, we're applying the ProWard transformations, and after that, we are applying the texting. Okay? With R8, it's going to be different. But we have to have clear, because we are thinking, D8, texting compiling, R8, ProWard. Well, it's more than ProWard only. R8, D8 is content in R8. So if you are using R8, you are using D8 at the same time. So, and what's the benefits? The benefits actually in size are more or less small, but the building time is quite spectacular. So take a look. We at the moment we are not testing, in production files, the ProWard, the R8, but we're trying. Okay. Then the repository is open source, of course, and you have the issue track for both, for D8 and R8. I recommend you because it's quite necessary to understand what problem you're handling. Okay, the last topic is the Android runtime, ART. And what is ART? So first of all, if you think about what is the stack of Android, so it's, you are an Android developer, you know, right? We have on top applications, we have the Android frameworks, and then we have like the native libraries and the Android runtime. It's like the virtual machine. To say one example, in the bottom we have the hardware abstract layer, and finally the kernel, right? Android-based Linux. This is today, but before we have the pre-lollipop versions, we have Dalvik, okay? And here you have to have one thing clear, and it's like Dalvik was the previous virtual machine, the previous runtime of Android, but the bytecode still is called Dalvik. So don't be confused, right? So Dalvik was the virtual machine. Now the virtual machine, the runtime is ART, but still the bytecode generated is called Dalvik bytecode, because we have to give support to the previous versions still. And what's the main difference between Dalvik and ART? Well, here we are entering in how we are executing the text files or applications. Think that the smartphones at that time, 2008, 2009, they had like a ridiculous memory, right? Memories, size, and Dalvik was using just-in-time compilation. What means just-in-time compilation? If you remember from the university maybe, and it was working like when the app starts to run, so we translate the bytecode to the machine code. And this was beneficial because it was less space and less memory. Okay? And it makes sense. Imagine 10 years ago, one small device, how we can execute fast one app. And this one was the best option with R8. But the time came with better devices and with better architectures. And R use ahead of time compilation. What's mean? In that case, ahead of time means that when the app is installed, we are translating the bytecode to the native code. Okay, you see the difference? So before was like when I'm running the app, I translating the bytecode to the native code, but with ahead of time, in the moment that I'm installing the app, I'm doing the transformation. And doesn't mean that the app is run faster, there is a better startup, and the battery performance. Here, that's from Wikipedia. You can see a better, well, it's very detailed. Because again, you have to provide support for Dalvik versions still. So if you are not using, if your min SDK is 21, you're okay. But some people know, right? And that's the thing. So this is here is where the Dalvik is getting the bytecode and transforming to the native code. But instead, in the ahead of time compilation with R, we are doing before, and that's something that is benefit. So I don't know if you remember in previous Nougat with Marshmallow, when you were getting one update from Android, at the beginning was like a dialogue saying that apps are updating, right? And this was this ahead of time compilation from R. But in Nougat, just-in-time compilation returns. And what's mean? So this is a hybrid model, actually, in Android. So instead of having to choose between just-in-time compilation or ahead-of-time compilation, we can try to create a hybrid model where we can try to profile the startup of the app with just-in-time compilation and then provide these results when we are installing the app. And that's giving up very good numbers. So this is in the difference between Marshmallow, right? Ahead of time compilation always is constant, is linear. That is constant, sorry, the time. But with Nougat, with this hybrid model, at the time as installed is a peak. But later, as we have profiled the bytecode, we have provided the optimization, we can give better numbers. And this is one thing that it was funny, right? Because the other day I was talking with the guys of the GDG here, and they told me that, the app of Agoda now is faster, it's very fast. And I was thinking, well, we didn't do anything, right? So in terms of the startup, right? And that's these improvements that they're not coming from the developers, they're coming from the Android runtime. You know, you getting my point? So that rely in the tools that we are using. In terms of Android P, what are the improvements? Well, we have Kotlin, memory and storage, and cloud profiles. In terms of memory and storage, we're going to talk a lot, but these text files, now they are using a compact DEX. That is a better approach to use the Dalvik executable files. In terms of Kotlin, there are some improvements that now, for example, if you have some problem of performance related with Kotlin, now it can be addressed in two directions. One, with JetBrains, and second, with the D8 or ART implementation. Let's analyze this simple function where we are creating an option from a menu. This is a bytecode, Dalvik bytecode, generated. And this is the problem. This generated intrinsic check parameter is not null. It's generated every time that you have a not nullable argument in a function, right? We saw before, with version U. And in terms of bytecode, is adding one code more in the stack. And if you multiply this for 1,000, for example, and it's a very small number, we are adding overheading the virtual machine in that case. So one of the improvements of the Android runtime is that they are inlining these functions. And it's like a small thing, but in terms of performance, it's much better. If still you want to know more about inlining, so Egg wrote this awesome article, and you can check more details about this. But in the previous talk of version U, we were talking about the same. Okay, and related with the cloud profiles, there is the last point. Do you remember the hybrid model that 2 minutes ago I was talking in Android Nougat, where we are mixing the just-in-time compiler from the startup and the ahead-of-time compiler. So with Android P now, you can use this in cloud, and this is, I guess, one of the best things that I'm trying to see if we can use more. So what's on this way? So imagine that you have your device and you have your app, and in the moment that you are running your app, so with just-in-time, for example, you are profiling your class, but not like in Nougat, that the profiling data was used only in your device. Now we are uploading to Google Play, and in Google Play, it's happening the aggregation of the data, and depending of the model, depending of a lot of parameters. So when we are installing the app, we are providing a profile guide compilation to use in your application. And that means that every time, or so many times that your applications are running in different devices, are generating better profiling for your future execution apps. So take a look, because I think it's one of the best features here. So in terms of Android runtime, look these results activating cloud profiling. So in terms of Google Docs, for example, they have an improvement on the startup time at 33%. It's a lot. It's a lot. So imagine that you have 1 second starting your app, and now you have all the 3 seconds. Of course, if your applications are simple and they are not using specific libraries, like the phone, for example, or the camera, they're not a huge improvement. But if your application has a lot of dependencies, for example, you need to profile, you need to give better results, it's going to be an awesome results. So, time to summarize now. In the first place, we have seen testing. In terms of testing, Project Nitrogen is coming at the end of the year, and Roboelectric 4 is giving us the opportunity to run espresso test in a unit test. Then we have the R8, new Dexing compiler, new shrinker compiler for the Android. Be prepared. R8 now is going to be in 6 months at the same level like DX, but you need to prepare your application. R8 is going to be the replacement of ProWord as well. And finally, in ART, we have seen a little bit of story, different ways to optimize the app with just-in-time compilation ahead of time, and checking that cloud profiling is going to be very good for applications. Of course, you have the presentations in YouTube, and almost all the content from this talk is coming from here. I recommend you, of course, what's new in Android runtime, best practice using compilers, using Android Studio, and the testing one. So before again, we are doing a workshop of Kotlin, but for Android developers. Okay, if you want to, you are still working in Android, so with Java, we are organizing this kind of workshop with Kotlin Thailand. Feel free to join us. In that case, it's going to be Thai and a little bit English, right? So, okay, and that's it. That's everything that we have. Thank you very much. Kopukap.